Welcome back to G-Fun Facts Online. Today we are dissecting what might be the most significant architectural shift in the history of the internet since the adoption of TCP/IP. For the last 30 years, the web has effectively been a digital library. It is a repository of HTML pages, videos, and images designed for one specific biological processor, the human eye. We navigate it, we scroll through it, and we click buttons. But that era is ending. A new layer is being built on top of the digital world we know, and it is called the Agentic Web. In this new economy, the primary actors are not humans. They are autonomous AI agents. These are software entities capable of perceiving, reasoning, planning, and acting. These agents do not just chat, they negotiate supply chains, execute financial trades, book complex travel itineraries, and manage entire enterprise workflows without human intervention. But here is the problem. For this vision to scale from isolated chatbots to a global, interconnected economy, we need a common language. We need a set of rules, interfaces, and trust mechanisms that allow a Google agent to hire a Salesforce agent to buy services from a Stripe-enabled merchant. This unified framework is emerging as the Agentic Standard. It is not a single document, but a convergence of open protocols, including the Agent-to-Agent Protocol, or A2A, the Model Context Protocol, or MCP, the Agentic Commerce Protocol, or ACP, and the Agent Payments Protocol, or AP2. Together, they form the constitution of the autonomous AI economy. In this episode, we are going to tear down the technical stack, the economic rails, the identity frameworks, and the future implications of a world where software writes its own checks. To understand the Agentic Standard, we must first understand the friction it removes. The current internet is fragmented. Application Programming Interfaces, or APIs, are designed for human developers to hard-code integrations. If you want your software to talk to Uber, a human engineer reads Uber's documentation and writes specific code. AI agents cannot read documentation and write code in real time for every new service they encounter. They need a universal interface, a way to plug in to any digital service instantly. This requirement has given rise to the agentic stack. Let's start with the foundation, the communication layer. How does an agent from one organization talk to an agent from another? This is handled by the Agent-to-Agent Protocol, or A2A. Originally championed by Google and the Linux Foundation, A2A is effectively the HTTP of the Agentic Web. It standardizes how agents discover each other and exchange tasks. It introduces the concept of agent cards. Think of this as a digital business card, or a LinkedIn profile for software. It is a JSON-based manifest, where an agent declares its capabilities. For example, I can book flights, or I can optimize Python code, and it declares its pricing models. When a client agent, like your personal assistant, needs a task done, it broadcasts a request. A2A protocols allow service agents to respond with bids instantly, saying, I can do this for 5 cents in 200 milliseconds. Once a bid is accepted, the agents perform a cryptographic handshake to establish a secure channel, ensuring that no malicious actor can intercept the task instructions. While A2A handles the connection between agents, we still need to solve the intelligence problem. Large language models often hallucinate when they lack data. They need context. This is where the Model Context Protocol, or MCP, comes in. Developed by Anthropic, MCP handles the conversation. It provides a standardized way for agents to fetch fresh context from external tools, like a live stock ticker or a private database, without needing custom integrations. Instead of building a Notion integration and a Slack integration, developers build a single MCP server. Any MCP-compliant agent can then read that server to understand the data structure instantly. It allows an agent to ask, "What data do you have about Project X?" and receive a structured, machine-readable answer rather than a blob of text. Moving up the stack, we have the operational layer. Agents are not stateless scripts. They are long-running processes. They need to remember what they did yesterday. The standard demands fault-tolerant orchestration. If an agent is midway through booking a flight and the server crashes, it must wake up and resume exactly where it left off. Protocols like Temporal are often integrated into the Agentic Standard to provide this immortality to agent workflows. Furthermore, the standard defines specific breakpoints where an agent must pause and ask for human confirmation. This is not just a user interface feature. It is a protocol-level safety check known as a mandate. Now, let's talk about the most disruptive part of this stack, the economic rails. An economy requires money. But giving an AI your credit card number is a recipe for disaster. The Agentic Standard introduces a new financial paradigm specifically for non-human actors. We have two key protocols here. First, the Agentic Commerce Protocol, or ACP. Co-developed by Stripe and OpenAI, ACP is the bridge between the old world of e-commerce and the new world of AI. Traditional checkout flows require a human to click buttons, solve CAPTCHAs, and enter a billing address. Agents get stuck on these screens. ACP allows merchants to publish a machine-readable checkout. Instead of a visual shopping cart, the merchant broadcasts a structured order object. The agent fills in the details programmatically and submits a tokenized payment credential. Crucially, ACP preserves the direct relationship between the merchant and the human user. The agent is merely a courier. This ensures that fraud detection systems, which rely on knowing who the human buyer is, still function correctly. But how do we authorize that payment? That is the job of the Agent Payments Protocol, or AP2. While ACP handles shopping, Google's AP2 handles the deep plumbing of authorization and liability. The crown jewel of AP2 is the concept of verifiable intent, also known as the mandate. When you tell your agent, "Buy me a coffee," the agent generates a cryptographic intent mandate. This is a digital contract signed by your private key that says, "I authorize Agent X to spend up to $5 at Starbucks." When the agent pays, it does not just send money, it presents this mandate to the payment network. The bank can verify that the human authorized this specific scope of action. If the agent tries to buy a car instead, the transaction fails at the protocol level because the mandate does not cover it. AP2 is designed to work with credit cards, but it is built for the future of crypto and stablecoins. In a fully autonomous economy, agents will likely prefer settling in USDC or Lightning Network Bitcoin, because these rails act as programmable money that matches their programmable nature. This brings us to the question of trust. In a world with billions of AI agents, how do you know the IRS agent emailing you is actually from the government and not a phishing bot? The Agentic Standard adopts decentralized identity and verifiable credentials. Every compliant agent is issued a decentralized identifier, or DID. This is a globally unique ID anchored on a blockchain or a distributed ledger. It ensures self-sovereignty, meaning the agent owns its identity and it cannot be deleted by a centralized server. If an agent is compromised, its cryptographic keys can be rotated instantly, but a DID only tells you who an agent is. To know what it is qualified to do, we use verifiable credentials, or VCs. These are essentially digital badges. An agent might present a VC signed by the American Medical Association that certifies it as a medical triage bot. Another might hold a VC from OpenAI certifying it is running GPT-5 with safety rails. We are also seeing the rise of protocols like Ethos and Deep Trust, which track an agent's history. If an agent fails to deliver on a task or acts maliciously, its on-chain reputation score drops. Other agents will effectively block it, creating an immune system for the Agentic Web. This entire ecosystem is not operating in a legal vacuum. By late 2025, major regulatory bodies have begun to catch up. The European Union's AI Act has effectively mandated the use of protocols like AP2 for high-risk autonomous systems. The law requires traceability. Every action taken by an AI agent must be traceable back to a legal person, whether that is a human or a corporation. The intent mandate in AP2 satisfies this legal requirement perfectly. Standards bodies are even debating the implementation of a universal protocol kill switch that allows authorities to freeze the assets or communication rights of a rogue agent swarm. The OECD has updated its framework to include agentic responsibility, reinforcing the principle that delegation does not absolve responsibility. If you delegate a task to an agent, you are liable for its outcome, which drives the adoption of the strict scoped permissions found in the Agentic Standard. To visualize the power of this unified standard, let us look at a few scenarios. Imagine an autonomous supply chain. A manufacturing plant runs out of a specific screw. The factory's inventory agent detects the shortage. Using A2A, it queries the global agentic network for suppliers of M4 steel screws. It finds 3 supplier agents and negotiates price and delivery speed instantly. It selects the best offer. Using ACP and AP2, it generates a mandate authorizing a $2,000 purchase. The supplier agent accepts the mandate and triggers the shipment. Upon delivery verification via IoT sensors, the payment is released automatically via smart contract. The time elapsed for this entire complex negotiation was 4 seconds, with 0 human involvement. Or consider a personalized travel concierge. You tell your phone, book a weekend in Tokyo, under $3,000, with lots of sushi. Your personal agent acts as the client. It breaks this into subtasks like flights, hotel, and reservations. It uses MCP to connect to a live flight data aggregator and a hotel availability engine. It books the flight. It negotiates a room upgrade with the hotel agent using your loyalty status, verified via a verifiable credential. It books a table at a high-end sushi bar using an automated reservation agent. Finally, it uses your stored card via ACP, passing a travel budget mandate that limits total spend to $3,000. Or consider institutional finance. An autonomous portfolio manager detects an arbitrage opportunity between two crypto exchanges. It proves to the exchange agents that it is a licensed trader using a verifiable credential from a regulatory body. It executes a flash loan, completes the trade, and logs the entire sequence cryptographically for audit. Looking forward, the Agentic Standard is currently in its dial-up phase. We are establishing the basic connections. What comes next is the broadband era of agency. We will move from one-to-one agent interactions to swarm dynamics, where thousands of micro-agents collaborate to solve massive problems, like optimizing a national energy grid. We will see the agentic metaverse, where agents inhabit 3D spaces. Standards are already being proposed for embodied agents, robots and drones, that share the same protocols as software agents, allowing your digital assistant to pay your physical robot lawnmower. While protocols like A2A, MCP, and ACP are leading now, we can expect protocol wars. Closed ecosystems may try to create walled gardens of agents, but history suggests that open protocols eventually win because the value of a network scales with its openness. The Agentic Standard is more than a set of technical specs. It is a new social contract. It defines how we, as humans, will coexist with independent digital intelligences. For developers, the message is clear. Stop building chatbots and start building agents. Learn A2A, implement MCP, and secure your endpoints with AP2. For businesses, the warning is stark. If your service is not agent-ready, you are invisible. In the near future, your most valuable customers will not be humans browsing your website. They will be AI agents querying your API. If you do not speak their language, you do not exist in their economy. The autonomous AI economy is open for business. The protocols are written, the standard is set, the rest is up to us. Thank you for listening to Fun Facts Online.